Example 3, again, it says integration by parts with a single term. These ones are a little more difficult, not a little more difficult, very much more difficult in determining the fact that you need to use integration by parts to solve this problem. So let's look at this first example. It says find the integral of the natural log of 2x dx. Well, that's pretty simple, right? The integral of natural log of 2x, well, that would be 1 over 2x times the derivative of that, which is 2, so I'm getting 1 over x, right? Yeah? No, absolutely wrong. That is derivatives. Make sure you never use derivative rules when you're integrating. Remember, we are going backwards. That was complete junk, what I just said there. So that's one of the things that I see on the test is people forget which direction you're going. We are not differentiating, we are integrating, okay? So if I saw something like this, maybe I'd try something like u equals 2x to try substitution at first. So I'd name du dx, take the derivative of both sides, would be 2. So dx would be du over 2. Okay, and so if I plug this in, I'd have the integral of the natural log of u, and then it would be du over 2, which would be 1/2 the integral of the natural log of u du. But I don't know the integral of the natural log of u. Heck, that's the whole damn point of the problem, is how do you integrate the natural log of something, okay? So I don't have an integral rule, so what does that mean? That means u substitution doesn't work. And in all honesty, until you practice, you're going to always want to try u substitution first. If that doesn't work, then you're going to realize perhaps you have to use a different technique, such as integration by parts. So integration by parts, this is really difficult for us to see. I have u du, and I have v, and I have dv. Again, I'm trying to choose two things here, and I know that when I have the integral of u dv, that equals uv minus the integral of v du. So that's my integration by parts formula, and I'm telling you it does work on this problem. It is not something that I would have thought of, because when we see integration by parts, we usually see a product of two things. Well, technically, this is always a product of two things. The first function being the natural log of 2x, and the second function being 1 dx. Technically, this is a product, and that is very hard for you to see. How are you going to know to do this? Well, anytime you're integrating the natural log, I'm telling you right now, you're going to be using integration by parts. So anytime you're integrating the natural log, just know that you're going to be using integration by parts. So I have two separate things that I'm trying to integrate. The first one being the natural log of 2x, two different functions that that are a product that I'm integrating. The first one is natural log of 2x, and the second one is 1 dx. Again, we usually make u the simpler of the two and dv the more difficult, but if I made dv the natural log of 2x, I don't know how to integrate it, so that one doesn't work. So what I end up having to do is I make u the natural log of 2x, and I make dv the remaining, which is 1 dx, okay? How do I find du? Well, I take the derivative. What's the derivative of the natural log of 2x? Well, the derivative of the natural log of 2x would be 1 over 2x, 1 over u, times the derivative of u, which would be 2. So this is where I'm getting my 1 over x. So du, the derivative of the natural log of 2x, when simplified, is 1 over x. How do I get v? Well, I integrate dv. So what's the integral of 1? Well, the integral of 1 is quite simply x plus c. Let's go ahead and plug this into the formula now. The integral of u dv, which is our original problem, is now going to be equal to uv minus the integral of v du. So u is the natural log of 2x, v is x, minus the integral of v, again that's x, du is 1 over x, and then don't forget we always need dx on those derivatives. Okay, so it seems to me that we have x times the natural log of 2x minus the integral of, well, x times 1 over x, isn't that just 1? Dx. So this is x natural log of 2x. Well, the integral of 1 is simply just x, and then you need your plus c at the end because we are actually integrating here. Look, this answer is perfectly fine with me. X times the natural log of 2x minus x plus c. You might have someone say, hey, you could factor out an x of this one. So that would be x times the natural log of 2x minus 1. And then again, your plus c. I don't care which of those two answers you have. Both of them are perfectly fine for me. You do not have to factor. Okay? All right. So anytime you are integrating the natural log function, you are going to use integration by parts with u being that natural log function in this class. That's not always, but in this class, that's what you're going to see on the test. If you see the integral of a natural log, use integration by parts with u equal to the natural log part. Let's go into example 4. This one, not so fun. All right. Again, I do have a product here. I know that u substitution isn't going to work. If you don't believe me, try it. You really only have two options for u. It'd be x cubed or x, and either way, it's not going to work. So if you didn't see that, try u substitution, fumble with it, and see that you're not going to get the integral in terms of one variable. You're always going to have x's and u's, so you can't integrate. So I do have a product here, so this means I'm going to use integration by parts, u du and v dv. Okay, so what is it? The integral of u dv equals uv minus the integral of v du. We have two things to choose from. Our first thing to choose from is x cubed. Our second thing to choose from is e to the x. Which one are we going to make which? Well, again, u being the simpler, where you take the derivative, it's easier. Dv being the more difficult. So let's see what we could do. I'm probably going to choose u to be x cubed in this case, because when I take its derivative, it does get easier. The derivative of x cubed is 3x squared, a lower power, which would make, and then we need our dx there, right? And dv, let's try e to the x dx. And what is the integral of e to the x? Well, it's simply e to the x plus c, but we don't need the plus c yet, okay? So remember, we're going to say the integral of u dv equals uv minus the integral of v du. So in this case, u times v would be x cubed times e to the x minus the integral of v du. So this would be e to the x times 3x squared dx. Well, crud. If I'm looking at this second part right here, that integral doesn't look too much better than my original integral. I guess it does look a little bit better than the original integral in the sense that I guess it's 1 less power of x. So what the heck do I need to do? Well, this means I need to do integration by parts again. So let me clean this up real quick. This is going to be x cubed e to the x. And then I'm going to have minus 3 times the integral. I'm just going to pull out the constant of e to the x times x squared dx. So I'm actually going to have to do integration by parts again on this one. So I'm not using my original u and v. I'm using a new u and v. I have u du, v dv. Again, I want u to be the polynomial part. In this case, it's x squared. And dv to be the remaining, which is e to the x dx. The derivative of x squared is 2x. We need to tack on our dx here. The integral of e to the x is still e to the x. So again, I'm going to have the integral is uv minus the integral of v du. So let's rewrite this entire thing. It's going to get messy, but let's do this. X cubed e to the x minus 3. And then when I integrate that using integration by parts, I have uv minus the integral of v du. So u is x squared. V is e to the x minus the integral of v, which is e to the x, du, which would be 2x dx. Holy crud. So I have all of this, and I still need to use integration by parts again. Okay? Well, let's do it. Let's clean this up and let's go through this. Not fun, but we can do this. So I have x cubed e to the x. I'm going to distribute that negative 3. I'm going to have minus 3x squared e to the x. Okay? And then I'm going to have, well, what would that be? A minus 3 if I distribute that minus 3 to both terms. And on the second term, I could pull out a 2. So I'd have the minus 3 times the minus 2. That's actually going to be plus 6 times the integral of x e to the x dx. So again, that's if I distributed the negative 3 and I pulled out that 2 as a constant multiple. So I have to do integration by parts again. So I'm going to have u equal to du. I have dv, and I have v. So let me erase that and put a v there. U is the algebraic part, the x. dv is the remaining, which is e to the x dx. The derivative of u is just 1. The integral of e to the x dx is e to the x. So I have x cubed e to the x minus 3x squared e to the x plus 6 times. Now I need to use the rule, the uv minus v du. uv minus the integral of v du. So uv would be x times e to the x minus the integral of v, which would be e to the x, du, which would be dx. I am still not done integrating, but the good news is that's a very simple thing to integrate. Let's keep on writing. X cubed e to the x minus 3x squared e to the x plus 6x e to the x minus 6. The integral of e to the x is e to the x plus c. Holy crud. And again, I just got that by distributing my 6 to both of those terms, and I integrated e to the x, and I know the integral of e to the x is e to the x. So what do I have? Well, everything has an e to the x in common. So this would be e to the x times, well, we'd have x cubed minus 3x squared plus 6x minus 6. Then we have our plus c. Heck of a problem, but that's what it is. How can you check to make sure this is the right answer? Find the derivative using the product rule. You will see if you find the derivative using the product rule, you will end up with the original problem, believe it or not, which is x cubed times e to the x. You'll have a bunch of terms canceling and everything. So you could always check this using the derivative. Holy cow. So we just had to do integration by parts 1, 2, 3 times plus another integral on top of that. So this is a huge pain. I do want you to notice that the original problem was x cubed e to the x. Because it was x cubed, that power tells you how many times you're going to need to use integration by parts. Because it was x cubed, I would need to use integration by parts 3 times. If that was an x to the 5th, I would have to do integration by parts 5 times. If it was x squared, I'd have to do it 2 times. So just notice that. That's a nice little trick for you to notice. The power on x is the number of times that you're going to need to do integration by parts in this particular problem when it's just x raised to a power times e to the x. Hope that helps.